All right, so our very last section in our conics chapter is classifying conic sections. So this is when your conic section is given to you in a general form, which I don't know what the heck is going on right here, but I'm gonna let it go. A general form, expand it out, and you can't just like look at it and tell what it is, right? So you have to identify what it is and then put it in its standard form, okay? So here's how you decide what it is. You're gonna look at the equation, okay? This is the equation that I'm looking at right now. Goo, okay? If it has an x squared, if it just has an x squared or it just has a y squared, but it doesn't have both, then it's automatically a parabola. So if it has one square in it, then it is a parabola, okay? Now let's talk about if it has an x squared and a y squared. If it has an x squared and a y squared, it could be one of three things. It can be an ellipse, a circle, or a hyperbola. So what you're gonna do is you're gonna look at each term with the x squared in it. So this term, each term with the square in it, so the x squared and the y squared. What you're gonna do is you're gonna look to see if there is a plus sign or a minus sign separating them. If it's a plus sign, you've now narrowed it down to a circle or an ellipse. If it's a minus sign, it's automatically a hyperbola, okay? So look at the sign. If it's a minus sign, hyperbola. Well, what if it's a plus sign? It's a circle or an ellipse. So then what you're gonna do is you're gonna look at the coefficients. If they're the same coefficient, it's a circle. If it's a different coefficient, then it's ellipse. All right, so what I want you to do is go ahead, pause the video, and try the next page where it's just identifying what it is. You're not doing anything else other than that. All right, let's check to see how you did. I also have highlighted the terms that I was looking at to decide whether it was one of those four things. Okay. All right, let's move on to notes for today. And you need to know that first part in order to do today's notes, okay, which is graphing and classifying conic sections. So what's going to happen is you're going to be given it to a general form, and you wanted to get it into one of these 7 standard forms, okay? So as a reminder, these equations will be given to you on your test, but this is exactly what it looks like on your test. This is it. So you have to know how to use it. You need to know what H and K represent. You need to know what A represents, B represents, P represents, R represents, all of those things. Okay, so directions are for each general equation, identify what it is, which conic section is, and then once you know what conic it is, you're gonna put it in its standard form and graph it, okay? All right, so let's go ahead and look at this first one right here. So you're gonna look for your quadratic, you're gonna look for your squared terms, and there's 2 of them, so I know it's not a parabola, all right? So I look at these 2 terms, okay? I can see that there's addition separating them, so it's either a circle or ellipse. If you look at the coefficients, they're the same, so it's a circle. So I need this to look like an equation of a circle. Okay, I'm gonna erase this highlighting here. If you look back at an equation of a circle right here, you have a binomial squared for x plus a binomial squared for y equals, and then it's a constant. And that's how we find our radius, but it's just a number like 25 or 36 or 106, okay? Just any number, right? So we want it to look like that. All right, so let's go ahead and get it to look like that. So first thing that we're gonna do is we're gonna reorganize this. We're gonna put all the x's together, then all the y's together, and then any constant on the other side. So we have 2x squared minus 12x plus 2y squared plus 4y is equal to, and then I'm going to subtract 2 from both sides, so -2. Some people skip this step, and when we skip this step, mistakes are made, so I highly suggest that you don't skip it. All right, so what you need to do is, if we need to get a binomial squared, we need to complete the square. We need to complete the square for x, and then we need to complete the square for y. So let's start by completing the square for x. Can we complete the square right now? Nope. Why not? Because it has a lead coefficient of a 2, and we need it to be a lead coefficient of a 1. So what we're going to do is we are going to factor the 2 out of those 2 terms. X squared minus 6x, and then we're going to leave a space to complete the square for x. Then we're going to do the same thing for y. Can we complete the square for y right now? No, same reason why, because it has a lead coefficient of 2. So we're going to factor the 2 out. We have y squared plus 2y. Make sure you're factoring a 2 out of both of those terms. and then equals negative 2. All right, now I'm ready to complete the square for x and complete the square for y. So we are going to look at the b value. We're going to take half of it, which is negative 3, and we are going to square it. Negative 3 squared is a positive 9. All right, so now I just messed with this equation. I just threw a 9 on the left-hand side. But by throwing a 9 there, I didn't actually just put 9 on that side. I put 2 times 9, which is 18 on this side. So I have to balance my equation by adding 18 to this side also. Now we're going to do the same thing for y. We're going to take half of the b value, which is 1, and square it. 1 squared is 1. By putting a 1 there, we didn't just add 1 to this side. We added 2 times 1 to this side, which is 2. So I have to add 2 to this side also. All right, so now we are going to factor, so we have binomial squareds. So we have 2 times, this is x minus 3 squared. All right, x minus 3 times x minus 3 gives us that x squared minus 6x plus 9. Plus 2 times y plus 1 squared, because y plus 1 times y plus 1 is y squared plus 2y plus 1. Equals, combine those 3 numbers, that's 18. All right, now it almost looks like a circle. If we go back to our circle and see what it looks like, the only thing is that circles have lead coefficients of 1, right? We know if they're the same, it's a circle, but we want it to be a 1 so we can graph it. So let's get it to be a 1. How are we going to get it to be a 1? By dividing by 2. So we're going to divide both sides of the equation by 2. When we do that, we divide everything by 2, each term separated by addition or subtraction by 2. And we have x minus 3 quantity squared plus y plus 1 quantity squared is equal to 9. And now it looks like the standard form of a circle. And we've done this, so this shouldn't be, like we did this in the circle section, so this shouldn't be like, oh, that was crazy, right? Okay, so now we need our center and we need our radius in order to graph our circle. Our center is 3, negative 1. And remember, that's r squared, so our radius is 3. So this is our important information to graph a circle. And now we are going to graph that, and we will be done with this one. 3, negative 1 is right here. Our radius is 3, so go right 3, go left 3 from the center, go up 3, and go down 3 from the center. 1, 2, 3. It's only 2. I was like, that looks weird. 1, 2, 3. All right, connect those 3 points to make your circle. Oh, sorry, it just always amazes me when it thinks that I'm drawing something that's not a circle. Okay, and there's your circle. Beautiful, right? All right, moving on to our next one. All right, so same idea. We're going to start with, what is this? Okay, so we have an x squared and a y squared with addition separating it, so it's either a circle or an ellipse. If you look at the coefficients in front of those two terms, they're different, so this is an ellipse. Okay, so if you look at what an ellipse looks like, it's very similar to a circle, right? Okay, so we need a binomial squared and a binomial squared, an addition separating them, and then an equal sign, and then notice that this is a number, but it's always 1. So it's very similar to a circle, okay? But like once we get that number right here, like on the last one, I already forgot what it was. It was 18, okay? We want it to be a 1. So we would divide everything by 18. Okay, so that's the only difference. The math to it is pretty much the same. Okay. All right, let's go ahead and do that. So first off, reorganize. Don't skip this step, please, because I don't want you to make mistakes. X is first, Y is next, and plus 9. Oops, not plus 9. Get 9 on the other side. Equals negative 9. All right, so now we're going to complete the square for x. Can we complete the square right now? No, because there's a lead coefficient of a 4. So we are going to factor the 4 out of those two terms. All right, now we're going to complete the square for y. Can we complete the square for y? Yes. All right, we can. So we are going to complete the square for y now. Right? We don't have to factor anything out of that one. Equals negative 9. Okay, so let's go ahead and complete the square for x first. We're going to take half of negative 6, which is negative 3, and square it, which is a positive 9. So by putting a 9 right there, I've added 36 to this side. So I'm going to balance the equation by adding 36 to this side. I'm going to take half of b, which is 3, and square it, which is 9. And by putting a 9 there, I've added 9 to that side. All right, so now I'm going to factor. So I have 4 times, and then this is x minus 3 quantity squared, plus this is y plus 3 quantity squared, is equal to 36. So now notice I'm at a point where it looks very similar to the circle. The only difference is for an ellipse, we want it equal to 1. So we're going to get it equal to 1 by dividing everything by 36. And then we're going to simplify any of our fractions that we can simplify. This fraction we can simplify. 4 goes in here once. 4 goes in here 9 times. The next fraction is not simplifiable. The last one is to 1. So now we're going to have it in our standard form. X minus 3 quantity squared over 9 plus y plus 3 quantity squared over 36 is equal to 1. So now it looks like an ellipse, and now we can graph it. So you can go ahead and pause the video and graph the ellipse on your own and then just compare it with mine. All right, so first off, you should have decided that this is a vertical ellipse because the second denominator is bigger. The center is 3, negative 3. I need my vertices, my co-vertices, and my foci. So my vertices are A units from my center, where A is my bigger denominator. That happens with an ellipse. So A is 6, so we're going to go vertically up 6 and down 6. So that's 3, 3, and 3, negative 9. My co-vertices are B units from my center, where B is my smaller denominator, so that's 3. So I'm going to go left and right 3, so that's 0, negative 3, and 6, negative 3. And then my foci are C units from my center, where C is equal to, C squared is equal to A squared, which is 36, minus B squared, which is 9. So we have C squared is equal to 27, square root, plus or minus. So C is equal to plus or minus 9 goes in there 3 times, so 3 root 3. So since this is vertical, I'm going up and down from my center. So that's 3 comma, negative 3 plus or minus 3 root 3. Holy moly, that's a lot of 3s in that problem. Okay, let's go ahead and graph this. I'm going to go ahead and box this important information so I have it. Okay. All right, my center is 3, negative 3. Vertices are at 3, 3, and 3, negative 9. Co-vertices are at 0, negative 3, and where I go, 6, negative 3. Go ahead and make your ellipse. Okay, and then I'm going to graph my foci. So my foci, I need to get an approximation of root 27, which is 5 point something. So from my center, I'm going to go up and down 5 point something. So up 5, 1, 2, 3, oops, I don't think that's my foci, 3, 4, 5, and I'm right in there, and there. And there's my ellipse. Okay. All right, moving on to the next one right here. I'm looking at this, and I only see an x squared. I don't see a y squared, so I know this is a parabola. So if it only has an x squared, I'm only completing the square for x, and that means that I'm going to get it, if I'm only completing the square for x, it's going to be a y equals. This is going to be a vertical parabola. So let's go ahead and do that. All right, so this is how I do it. I isolate this and get it by itself and get everything else out of the way so I can complete the square for x. So I have x squared plus 14x, and then I'm going to leave a space to complete the square for x. The lead coefficient's already 1, so I don't have to worry about factoring anything out first. And then I'm going to get everything else out of the way by moving it to the other side of the equation. So I have equals 4y minus 29. All right, so now I'm going to complete the square for x, take half of 14, which is 7, and square it, which is 49. And then I just added 49 to this side, so I have to add 49 to the other side. Factor that trinomials, that's x plus 7 squared, and then equals 4y. I combine those two to get plus 20. All right, so it almost looks like a parabola, but I need it to be solved for its variable with a coefficient of 1. So I need to get y by itself. So to get y by itself, I'm going to subtract 20 from both sides. And then lastly, I'm going to divide both sides of the equation by 4. Remember, this term and this term are two separate terms, so I'm going to make sure I divide both of those by 4. You can put it all over 4 and make sure you divide by both, but I just separate it. All right, so I have y equals, remember this is the fraction 1/4, and then x plus 7 quantity squared. Negative 20 divided by 4 is minus 5. And there's your parabola. All right, you can go ahead and pause the video and graph that. Remember, you need to decide the orientation and then find the vertex, the focus, and the directrix. You'll also need at least 3 points for accuracy. All right, so you should have that this is a vertical parabola facing upward. The vertex is -7, -5. I need the focus and I need the directrix. The focus is p units from my center. From my vertex. P is 1, all right, because 1/4 equals 1/4p, so P is 1. So I'm going to go up 1 to get my focus. That's -7, -4. And then I'll go down 1 to get my directrix, which is y equals -6. There's some important information. I just also need a table of values. So I'll make my table of values, x, y. I need at least 3 points. I already have my vertex, which is -7, -5. And then I will plug in -6, and I will reflect -8. So plugging in -6 here, I have -6 plus 7 is 1. 1 squared is 1. 1 times a fourth is a fourth. 1/4 minus 5. I'll write that down just to make sure we see it. Is -4 3/4. All right, I'm going to go ahead and graph this information. I have -7, -5 for my vertex. I have my focus is at -7, -4. My directrix is at y equals -6. And then I also have the points, -6, -4 3/4, and its reflection. So I have this upward facing. If I had $1 for every time that happened to me, I'd have a lot of dollars. All right, there is my upward facing parabola. All right, we have one more, and it's hyperbolas. I shouldn't have said that before I did it, but obviously. And then you have some to review problems to try. Okay, so let's not assume it's a hyperbola, but if you look x squared and a y squared, subtraction separating them, so it's a hyperbola. Okay, now for a hyperbola, you're going to do the same thing as you did for an ellipse, okay? You're going to put your x's together, your y's together, your constants on the other side, get it equal to 1. There's 2 things you have to be careful about. First off, a hyperbola, let me go back to the beginning right here where our equations are. Hyperbola can start with x squared or y squared, so you don't want to reorder it. Whatever comes first. If it's an x squared first, then your x squareds are going to go first. If a y squared comes first, then your y squareds are going to go first. Okay? Also remember that you're factoring out a negative at some point, so you just have to be careful about that. Okay, let's go ahead and do it. So let's go ahead and rearrange this. Everything with an x in it first. X squared, there is no x, which is just less work for me, great. Then my y's, so I have -y squared and plus 36y. And then get everything else on the other side, so add 45 to both sides. All right. So first off, I'm going to complete the square for x. It's already complete. It's just an x squared. Done with that. Now I'm going to complete the square for y, which I can't complete the square yet because it has a lead coefficient. What is the lead coefficient? negative 9. Don't say 9, it's negative 9. So I have to factor a negative 9 out of those two terms. Not just a 9, a negative 9. So I have y squared minus 4y, leave a space to complete the square for y, equals 45. All right, once again, x's square is already completed. I'm going to complete the square for y. Take half of negative 2 and square it, which is positive 4. By putting a positive 4 right there, I've added negative 36 to that side because it's negative 9 times 4. So I have to add negative 36 to the other side, or subtract 36 from that side. All right, now everything else is done the same way as an ellipse. So we have x squared minus 9 times, factor that, that's y minus 2 quantities squared equals, combine those, and you have 9. And then I need it equal to 1, so I'm going to divide everything by 9, and then simplify my fractions. So I have x squared over 9 minus, these 9's simplify to 1. So you can either write y minus 2 squared and then just not over 1, but know it's over 1 equals 1, or you can put it over 1. It's up to you. Okay. All right, you can go ahead and pause the video to graph your hyperbola. Remember, you have to decide the orientation, the center, the vertices, and the foci. Okay, so this is a horizontal hyperbola. I can tell because x squared comes first, then y squared. My center is 0, 2. My vertices are a units from my center, where a is automatically the first term, or sorry, first denominator. Sorry, a squared is the first denominator. So I'm going to go horizontally 3 units. That's right 3 and left 3. So that's 3, 2 and negative 3, 2. For my co-vertices, there are no such thing, right? So I'm not finding those. I do, however, need to find foci. All right, my foci are c units from my center, where c squared is equal to a squared plus b squared. So c squared is equal to 10 square root plus or minus. So I am going horizontally, positive and negative root 10 units from my center. So that's from 0. So I'm going to say plus or minus root 10, comma 2. All right, now I'm ready to graph. All right, my center is 0, 2, right there. My vertices are 3, 2 and negative 3, 2. And then my b value is 1. So I'm going to go up 1 and down 1, and then I'm going to make this into a rectangle. Oh, I also need my equations of my asymptotes. Should do that also. Here are my 2 hyperbolic branches. 1, 2. My foci are root 10 units from my center. Root 10 is a little bit more than root 9, so it's 3 point something. And the graph is done, so this is approximately 3 point something. But I should also do my equations of asymptotes. So it's going through the center, so that's y minus the y value on my center, which is 2, equals. There's a positive and negative slope line. And then my slope is b over a, so that's 1 over 3 or 1/3. And then I could always double check to make sure it's not 3 over 1, but if you look, it's up 1, right 3. And then x minus h, which is x minus 0, which is just x. And there's my other important information. Box that. All right, that's it for today's notes, but there is 2 more review problems, so I want you to pause the video, try those review problems, and here are the answer to those review problems. See how you did. All right, you can go ahead and get started on the homework.